Power to your PC starts in a C6 or C8 port with 110 to 240 volts operating at 50 to 60 Hz. It moves through a capacitor, through a high frequency controller, then a transformer before it's smoothed and supplied to... Oh, I think I'm moving so fast. Let's go slow. Here are some things that you need to know before we proceed. This is a technical video, no doubt. I'll try to babysit you through the jargon, hoping you actually understand how this small thing works. This type of wave is known as a square wave. It turns on and off between two values. The ratio of its on time to the total cycle time is called the duty ratio. Remember this because it will be very important later, duty ratio. A MOSFET is an electronic switch that you can turn on and off by supplying a voltage into one of its pins. What actually happens is this. Power flows from the mains through an inductor which allows 50 to 60 Hz frequency from the mains to pass into the charger and prevents very high frequency from the charger from getting back to the house wiring, which would make your whole house become an antenna, interfering with your phone's network. The actual process it blocks high frequency is kinda weird and out of scope of this video, so let's skip that. The brown component here is an X-capacitor. Together with the inductor, they form a choke that keeps the house wiring clean of high frequency noise. The alternating voltage is then converted into a pulsating DC signal with this bridge rectifier. The 4 rectifier diodes you have probably seen in high school classes are all inside this one block. The pulsating DC, which is up to 340 volts, then passes through a bulk capacitor which smooths it into steady DC. Some of that steady DC is tapped off to run a controller IC. This IC then turns a MOSFET switch on and off thousands of times a second. This creates a square wave at a controlled duty ratio. This square wave can then pass through the transformer and is stepped down to the required voltage. The square wave on the transformer output is converted to DC by this block called a dual Schottky diode. Then it's passed through output capacitors to smooth it back into steady DC. Some of that steady DC is fed back to the controller through an optocoupler, which is an isolated device that allows transfer of voltage from one side to another using light. This feedback voltage allows the controller to vary the duty cycle to ensure that the output always stays the same regardless of the variations in input voltage. To protect the PC from overcurrent, which would cause a fire, the current into the transformer must flow through a very low value resistor around 2 ohms. The voltage across that resistor is measured by the controller. When the current flowing through the transformer suddenly increases, the voltage across that resistor also increases. This is true by Ohm's law. The IC detects it and immediately turns off the MOSFET switch. This protects you and your PC from an electric fire. These switching components generate a lot of heat. Thus, the MOSFET and the dual diode are bolted onto large metals. Take a look at the one here. These metals are then glued together with the transformer onto a larger metal sheet that conducts that heat onto the plastic casing, keeping everything somehow cool. To the components inside, it's actually cool, but to your hand, that might not be the case. Now, have you seen this cylindrical thing towards the computer? It's called a ferrite bead. It's a cylinder made of iron oxide and other metals. The charger wires actually pass through the middle of that cylinder. Without this bead, the cable would work like an antenna, broadcasting all high frequency noise from the power stage into your house. This would affect your Bluetooth and Wi-Fi like EMP. I won't go deep into EMP because some of you might be planning bad things. So what it does is that it suppresses the high frequency noise that might have proceeded to your PC. Why is it placed at the absolute end of the wire? It is so that it catches the noise that persists along the entire length of the wire at the final point of entry. This is just like you are denied entry to university after high school. We have to first wait for you to reach the end of high school, then test if you actually qualify. You see, you get. See you in the next video. Live safe.